So question 1 is really focusing on the idea of this word factor. What does factor mean? And that's what we're exploring. That's what we did last week, and that's what we're going to explore this week. So one of the things you can do is create that factor tree when we just have numbers, right? So going back to dividing this, I know 5 times 77 gives me 385, but we can rewrite 77 as 7 times 3. So the important thing just to kind of think of is a better way to write, well, I shouldn't say a better, another way to write 375 is 5 times 7 times 11. And that's the idea that we really want to get into today, is that when we find factors, remember what a factor is. It's a multiplication of all of the factors gives us the initial amount that we started with. Well, what happens if it's not just numbers and it's polynomials? How do we break that down? And one of the things we studied last week was different methods for factoring polynomials. So what are the factors? Really, we're just saying factor, but more specifically, what method would we use to factor this? Grouping. How do we know that it's grouping? 4 terms, right? So you're going to have a quiz on, or you had a quiz on Friday, and one of the questions was a grouping one, where it says group the first 2 terms, group the last 2 terms, and then we're going to factor out a common piece from each group. So the red one has an x squared, and what's left over is x plus 1. The blue one, we can factor out a negative 4, and what's left over is an x plus 1. And then this is the spot where you don't have to do this, but I think of us having a left side and a right side. And it's usually this stuff that students get confused on, but what do both sides have in common? They each have a factor of x plus 1. So we're going to factor that out. And then what's left over is the x squared and the minus 4 grouped together. And then we always ask ourselves, can we factor either of these parts further? Well, the x plus 1 is factored as far as it can go. But the x squared minus 4, that can be broken down into x minus 2 and x plus 2. So think of what we just did. We took a polynomial that had 4 terms to it. Its highest degree was 3, so this is a cubic polynomial. And we broke it down into 3 different pieces. Each one of these pieces is called a factor. Right? And it's equivalent. It's very important for us to understand that this expression is equivalent to this expression. And if we just FOILed everything out, we would get back to where we started. Okay? So that's what we need to really understand going into the new material today. Here's our quote for today. People don't notice whether it's winter or summer when they're happy. Okay. So if you want to write the title, it's right here. You do not have to write this idea of long division. But I'm going to show you it just to kind of make a connection of what we're doing today. Alright, so what is long division? You might remember this, but I'm looking for how many times does 13 go into 2,175? And if we do the long division, we're going to see not really how many times 13 goes into the big number all at the same time, but we're going to do it in pieces. So I'm going to start with the 2. Well, 13 doesn't go into 2, so then I have to move to the 21. And if I multiply that by 1, remember we multiply here, 13 times 1 is 13. And then I always like to think of this, instead of subtraction, we add the opposite. So I'm going to change this to adding the opposite. And when I do that, I get 8. Now what happens then is I kind of think of this as a brand new problem. I didn't use the 7 or 5 and that drops down. So now I'm going to go ahead and repeat the same process over again. 13 doesn't go into 8 evenly, but 13 goes into 87 a certain amount of times. Now, how many times is that? Probably 6 or 7. So let's see, if I did 6 times 13, 6 times 10 is 60, 6 times 13, 6 times 3 is 18. So that would be 68. Maybe we can get another one. Let's try 7 and see. So 7, I might put a 7 here. I think it'll work. No, it won't actually. Because 7 times 13, 7 times 10 is 70, 7 times 3 is 21, and that's 90. So that's too much. So that means I have to use 6. And what was that? That was 78, I believe. And then we're going to think of this as adding the opposite. Okay, and I know it's subtraction, but think of it as adding the opposite. When I add those together, I get 95 left over because the 5 drops down. And then I want to think, how many times does 13 go into 95? Well, I just checked 7. So 7 times 13 was 91. And we're going to add the opposite. Then I'm left with 4.
I'm sorry. Do you have any idea how the students are supposed to be doing the test?
Yeah, they open up on their laptop. There's an icon on it. They just open that up, and then we give them the ticket that has their.
So they don't log in first. They just click the.
They have to sign in to their laptop.
They said I've looked. There's no icon.
Is it a school computer or is it somebody else's? Okay, as you guys can see, there are going to be some issues with the MCA rollout. So now I'm at the spot where can 13 go into 4? And the answer is no. What did we call that for?
Remainder.
That's a remainder, right? That's what's left over when we solve this. Now, what's my answer? Right? That's usually the spot where kids are so used to doing this, and for some reason in middle school or whenever you learn this, you just stop right here. This is an answer, right? The answer is how many times does 13 go into this number? Well, it goes into it 167 times, but it doesn't go in even. There's a remainder, and how do we write the remainder? Well, it's added to the 4/13. So this is the final answer here, where if you were to figure out what 4/13 was as a decimal, you would get 167 point whatever 4/13 is. Okay. Now, why would I show you this? This is one of the things we're going to be doing today. However, it's not regular numbers, it's with polynomials. Some students actually prefer the polynomial method a little better. I don't want you to write this. I will post these notes, so if you feel like this is something that maybe you wanted, you can always go back and look at it. But how do you know if a number is a factor? Right? 13 wasn't a perfect factor of 2,175. Why wasn't it a perfect factor? Or what would happen if I had a perfect factor? What do you think your remainder is? Something goes into something exactly perfect. There's nothing left over. So your remainder is 0. And that's just important to notice. If something is a factor, then you will not have a remainder. Your remainder will be 0. Okay? Well, again, what is a remainder? It's the stuff that's left over after performing division. So let's see how this works with polynomials. It's been my experience that if I show you an example first, I do not want you to write this. And some of you are going to be like, whoa, that looks complicated or that looks tricky, I should write it. Don't. Watch how the whole thing works out, and then you'll get a feel of the big picture, and then we'll do more specific notes. We'll do another example for division. So, what are we doing? We have a polynomial divided by another polynomial, and they're telling us to use long division. Now there's a special note here. We'll hint this out as we go along, but it says if you have any missing terms, you can or you should fill them in with a creative zero term. I'll show you what I mean by that. Think of that zero as a placeholder. So what do I mean, any missing terms? Well, I have x to the fourth, then I have x to the third. What's missing? Something that's squared, right? We don't have a squared term. So I'm going to take that expression, and I'm going to put in a creative form of 0. Right? 0 times x squared is still 0. So now I have all place values from x to the fourth all the way down to the top. And then I'm dividing by x squared plus, well, wait a minute, I have another missing term. Right here, I don't have an x. So I'm going to put a 0x as a placeholder, and then I'm going to put plus 5. So it's basically the same setup as what we just did, but now here's the tricky spot. My goal is to come up with a number right here, and I want to multiply it by all three of these terms. But my goal is to make that first term look exactly like this term. So I have x squared. I'm going to multiply x squared by 3x squared. And when I do that, 3x squared times x squared gives me 3x to the fourth. That's your goal, is to make the first term match up. And then I do have to follow this. So 3x squared times the red 0x is 0x to the third. And notice how that aligns them. If I didn't have that 0x, I wouldn't have my spacing or my placeholders mapped out. And then 3x squared times 5 is 15x squared. All right, now here's the tricky spot. A lot of students see this and they're like, oh, I'm just going to subtract. You want to think of this as adding the opposite. Now, when I say opposite, every term is going to turn the opposite sign. And once that happens, then you can just add them together. So 3x to the fourth plus negative 3x to the fourth, add up to 0. What's left over is a negative 5x to the third minus 15x squared minus x plus 2. Everything else just drops down, and now it's like a brand new problem. We start the process all over again. Okay, so now I'll go to the next one, and my goal now is to make this x squared look like negative 5x to the third. So I'm going to multiply it by a negative 5x. You do not have to draw the arrows because it does get kind of messy. However, the students that draw the arrows, remember we multiply all of these three terms by negative 5x. So let's follow the first arrow. Negative 5x times x squared is negative 5x to the third. Negative 5x times 0x is 0x squared. And then the last green arrow, negative 5x times 5, is negative 25x. And then again, we're going to add the opposite. Now notice what happens, the opposite sign. So instead of a negative 5x to the third, that's a plus. If this was a number that we needed, it would be a negative 0. This would be a plus 25x. So now we'll add the opposite, which reduces out the first term. Leaves me with negative 15x squared minus plus 24x. And then the 2 we haven't used yet, so that drops down. Okay. And now we're going to keep going. Now it's a brand new problem. You can kind of think of it that way. Let's do, I don't know what's a good color, orangey. So now I have to make my leading term here, the x squared, look exactly like negative 15x squared. So I'm going to multiply by a negative 15. And again, you can see how messy the arrows get. So hopefully, in the long run, you don't have to do all that. But it does help just organize items. So, negative 15 times x squared is a negative 15x squared. Negative 15 times 0x is a 0x. And negative 15 times 5 is negative 75. So then, we're going to add the opposite. So all of these will change signs. And then we can add them together. My first term should always reduce out to 0. What's left over? 24x plus 77. Now, here's where you got to look at, how do you know when you're done? Well, there isn't any polynomial number, any monomial term that I can multiply by where an x squared will turn into a single x to the first power. So as soon as your squared out is higher than the number down here, you're done. And there's my remainder. But again, this isn't my answer, right? This is all the work that leads me to this answer. So what is the answer? How many times does x squared plus 5 go in? It goes in with this top polynomial. So 3x squared minus 5x minus 15. Plus, it doesn't go in evenly because we have a remainder. So now I'm going to take that remainder of 24x plus 77 divided by, what did we divide by originally? The x squared plus 5. Okay. Now, this might look really intimidating because it's a lot of work, right? But I wanted you to see the big picture first so you didn't just get caught up. And here's what I thought my hopes were. The first time we did it with the blue part right here, you might have thought, I'm not sure what's going on. And then we did it with the red, or green, and you kind of saw, oh, that was very similar to what we did the first time. And then you saw it with the orange, negative 15, and you're thinking, I'm starting to understand this process. So, let's do one together where you get formal notes. Now, I wouldn't write this exactly. I mean, it's up to you. If you want to write it like this, you can. But we have to set this up so it's in the form to do long division. So if you want, you could just start with what we're going to do here. I'll give you time to write everything down, though. Do I have any missing terms in my original polynomial? Right, we have x to the third, and then we go down to 2. Technically, there's always a 1, and then we have a constant. So there are no missing terms. But what about what we're dividing by? Well, I have x to the first, and then a constant. So there are no missing terms, which means I do not have to put in a placeholder of 0 anyway. So let's go ahead and start. And my goal is to take this x and make it look like an x to the third. Well, what do I multiply x by so it turns into x to the third? Squared. Okay, so we're going to put the x squared here. And since this is our first example, let's draw a couple arrows. We might not draw them for everyone. And remember, the arrows are telling us to multiply those terms together. So I'll get x squared times x, which will give me x to the third, and that matches perfectly. And then I've got x squared times negative 3. We have to be very careful here. So once I get done multiplying, some people say subtraction. I don't like that. I like to think of it as we're going to add these terms together, but they have to be the opposite sign of what they originally were. So we say add the opposite. So now, the x to the third, one positive, one negative, those are going to add up to 0, which is what we want. We're reducing terms out. And then I'm left with 3x squared plus 3x squared, so 6x squared. And then think of everything else as just dropping straight down. And now, it's like a brand new problem. We're going to start that same exact process over again. But this time, my goal is to make the x look like 6x squared. So what will I multiply by? 6x. Again, if you want, you can draw your arrows. But we get 6x times x, which is 6x squared. And 6x times negative 13 is a negative 18x. And some people get annoyed, but I'm going to write add the opposite again. We'll change this to addition, opposite of any sign. And you'll notice the 6x squareds add up to 0. And then I'm left with a 16x plus 7. The 7 dropped down, we didn't use it yet. And now it's the exact same thing. We're going to go ahead and grab a new So now we're going to multiply this x by a positive 16. Again, make sure you're multiplying. So I get 16x minus
48.
48, thank you. You do not have to write the word add the opposite. The reason why I do is you'll never forget it if you keep writing it because you're probably annoyed by it, right? So I'll change this to add the opposite of each piece. And then your 16s reduce out, and you're left with 56, 55. And x cannot be turned into 55, so that's how I know that I'm done. So what's my answer? Well, x minus 3 goes into this polynomial, and what's left over is this piece plus the remainder of 55. Now, when we say remainder, some students like to put the R here for remainder. The remainder is always divided by whatever we were dividing by. We were dividing by x minus 3. And there we go. So notice, my factor was not 0. Because it was not 0, it tells me that x minus 3 does not perfectly divide into this original function. Okay? If it was 0, that's a really good sign. And we're going to explore that coming up here. Okay. There is another way for division, and we're going to talk about something called synthetic division. And I know you're probably thinking another way. I'm not comfortable yet with long division. Okay, we'll get there. Technically, you'll see long division works for any possible division process. This idea of synthetic division does not work every time. So, definitely write this little box down. Okay, the first thing, and it's the most important thing, is this idea of synthetic division, you're going to probably like, because it's less work and it's faster. But it only works when we're dividing by a linear factor, something like x minus a. Right? That could be x plus 5, or x minus 7, or x minus 10. Right? anytime you're dividing by a linear factor, you can use synthetic division. So, any of the examples we've seen so far today, we were not able to do this idea of synthetic. Now, we kind of hinted at this. If you do any type of division and the remainder is equal to 0, then that x minus a that you divided by is considered a factor of the original polynomial. That's a special theorem that we're not really going to make a strong case for. It's called the Factor Theorem. But it basically is, if you can divide and you get a 0 remainder, whatever you divided by is part of the factor of that original expression. And then, as always, this is true for any method, don't forget your place values. Right? If you forget an x, if there's a missing term, we fill it in with a 0. And I think similar to the way we did long division, I'm going to let you guys watch the process and then just kind of see how it works, because it's a little tricky again, and I don't want you to be caught up on all the small details. Let's look at the big picture first. So don't write this part down here. It says, given the polynomial f of x and a factor of f of x, factor completely. Well, look at this. If this piece right here is already a factor, what do you expect to get as a remainder? 0, right? From right here. If you have a 0 remainder, then whatever you divided by is a factor. So if they tell us it's a factor, then I should expect to get a 0 remainder. So let me show you this. I'm going to make it a little, well, I think I can make this bigger. Okay, so let me rewrite this. That's kind of blurry, and I'll love it. So I have x to the third. I have 2x squared minus 51x plus 108. Now notice, 3, 2, 1 constant. I don't have any missing terms, so I'm in a good spot there. And they're telling me to divide, or they're actually saying that one of the factors is x plus 9. So, this is a little weird, but watch how synthetic division works. What I'm going to do is I'm going to take the coefficients, the numbers in front. So I'll take the 1, and then I've got the 2, and then I got a minus 51, and I have a positive 108. So notice I didn't write the variables. I just wrote the, you should not write this, no. I just wrote those pieces. Now, what we're going to do is we have to find a number that goes into those. To do that, we need to figure out what is the 0 of that factor. Okay? And to do that, we just set whatever we're dividing by equal to 0. And we're going to put that answer right here. Okay? So x plus 9, its 0 would be a negative 9. And watch how this synthetic works. Okay? We drop down the first term every time. And then we multiply to go back up. So I'm going to take this 1 and multiply it by negative 9. So 1 times negative 9 is negative 9. And then to go back down, we're going to add those two terms together. So 2 plus negative 9 is negative 7. To go back up, and maybe I should have drawn the arrow, to go back up, we multiply. Negative 9 times negative 7 is a positive 63. We add to go back down. So what is that, 12? Yeah. and then I multiply negative 9 by 12 to go back up. And that is 90, I think that's negative 108. And then we add to go back down, and what do you notice? 0. Now, this is tricky, right? You're still thinking, you're just making stuff up, which kind of looks like it. But let's look at what's left over. If that term is my remainder, then the next term here is always the constant term. So this next term would have to be the one that has the x value, and this term would have to be the x squared. So all of that work gave me an answer. If I took and factored this out, now notice they say factor the full function, so I want to factor this given f of x. Well, wait a minute. X plus 9 was already part of the answer, and what's left over is a trinomial. X squared minus 7x plus 12. Remember last week we were learning methods for factoring. We were learning ways to break things down. Well, what if it doesn't work? Then synthetic or long division can help us if our remainder is 0. But as we had last week, are we done? Could I factor further? And instead of doing more long division and all that crazy stuff, we could do this in our head probably. What are factors of negative 7, or excuse me, of 12 that add up to give me negative 7? What times what gives me positive 12 but adds up to give me negative 7? Negative 3, negative 4. And this expression is what we would call factored completely. So let's think about what we just did here really quick. We were given a big polynomial. Now notice, it has 4 terms, but grouping doesn't work. We could test it, grouping doesn't work. But I knew that x plus 9 was a factor, so I used either long division or synthetic. And I factored that out, and I found out what was left over. That's the blue x squared minus 7x plus 12. And then I factored that even further. All right, so I think you guys will get the hang of this. It just, sometimes it's being exposed to multiple types of problems. So let's try synthetic and just give you guys some feedback on how to do this. And I fully understand, because every year I teach this, kids, they're shaky, right? It's not something you're going to master on the very first or second time you see it. It takes some time. So, here's the original problem. Now notice, it just says divide. It doesn't say that this is a factor. So what I want to do is I want to rewrite this. And I'm just going to sneak a 0x squared there, because there's not an x squared term. So I need to put that place value of 0. And then we're going to take the coefficients. So we're going to take the 1 and then the 0, because we're going x to the third and then x squared. And then we'll take the minus 5 and the plus 3. So those are just the numbers in front. We're not dealing with the variables at all. And then I have to think of what makes what I'm dividing by 0. You can do all that in your head, but what would x have to be for this to be a 0? 2. Right? If you don't like that, you can set it equal to 0 and then go ahead and solve. But that's how we get that number. Now, some students often get confused or stuck because the very first thing you need to do is just drop down the first term. And I'll try to give you more specific details on how this is written. To go back up, we always multiply by the 0 term. So 0 times 2, 2 times 1 is 2. And then to go down, we add. And I'll write that down here so you have that as a little hint. So that's how I get 2 to the next spot. And then to go back up, we multiply by that regular blue 0, the 2 of them. So 2 times 2 would give me 4. And then we add to go back down. So it'll be negative 1. And then we multiply to go back up. And I usually do this one in a different color because it's the last term. And that last term is my remainder. And then remember what the rest of these terms are. That's my constant variable. So that's the one that doesn't have the x. And then we can go ahead and just put an x here. And then we're going to go up by 1 more and put an x squared. So my overall answer is x squared plus 2x minus 1 plus the remainder. The remainder is 1, but we have to put it by whatever we divide by. So I'm gonna let you guys, once we get this set up, I'm gonna let you try it on your own. Before you even start writing, do you notice if there's any terms that are missing? Just the x. And you have to notice that, right? So I've got x to the 4th, 3rd, 2nd. I have a 0x. So that's gonna kind of fit in right here. Remember, you can always sneak, if it's just a single term like x squared, you can always put a 1 in front, because there's always a 1 present if the variable's there. And then what number is going to go right out here? Negative 3, right? Because if we find the 0 to this linear term, that's a negative 3. And then remember how every problem starts once it's set up is the first number drops down. So why don't you go ahead and try that, see how far you can get. So remember the green arrows mean to multiply to go back up. So negative 3 times 5 is negative 15. And then when we go vertically back down, we add those together. So I get negative 17. And then I have to multiply to go back up. So negative 3 times negative 17, is that 51? We get a positive 51. We add to go back down, and we get 52. And then negative 3 times 52. That, thank you. Negative 156. Add to go back down. And this is where I really need your help. Thank you. 468. All right. And then add to go back down. And I want to do that one in just a different color. Doesn't really matter, but I always do that in different colors, so I kind of know that's my remainder. And then what I like to do is, I don't write the word constant every time, but I know that there's my constant, so then I have x, x squared, and x to the third. You're always going to build up from that. Okay. So then my answer is 5x to the third minus 17x squared plus 52x minus 156 plus the remainder of 458 divided by x plus 3. So, notice every problem we looked at with synthetic division, we can only use synthetic division when what we're dividing by is a linear term. So x minus 2, or in this case, x plus 3. If it had an x squared or an x cubed, we could not use the synthetic division. Now, look at how many different terms we have. 1, 2, 3, 4. The benefit to doing synthetic division is it's faster than long division, right? If I did this with long division, I'd have to do 1, 2, 3, 4 different levels, actually 5, now 4 different levels of long division. That might take up your entire paper. So that's the reason why, one of the reasons why synthetic division exists. So here's what I'd like you to try. Long division works anytime, anyway. Synthetic division only works when it's linear. But let's get across this idea that, if possible, you could do it both ways. And you should get the same answer for both of these. So I want you to try one with long division, and I want you to try another using synthetic. And it does work for synthetic because x minus 2 is linear. Okay? And then there are no missing terms, so nothing. All right, so there are the answers, long division and synthetic. You can see the benefits to synthetic, right? And that's why we teach it, is because if you're allowed to use synthetic, it's much faster, less chance for error. There you go. The downfall is it only works when you have the linear model. You can't do synthetic for any other method, and that's why we have to also know long division. Now here's the other thing. In the long run, in the grand view of things, if you don't remember synthetic, that's fine. But moving forward, even into calculus, we revisit long division. So long division is the one that you want to make sure you get and you know it every time. It's kind of like the quadratic formula, right? Quadratic formula works every time we're solving. Long division will work every time we're dividing. Okay? So today was a lot. And I know you're probably not super confident in this, because you shouldn't be, because we only did a couple examples of each, mostly because of time. But we're doing a Delta Math homework tonight. Please make sure that you are, when you answer a Delta Math question, you're typing in your answer very specifically like this. Because what I could see is that some students accidentally mistype something, and they get the answer right on paper, but they're just not typing it in correctly, and that could cause some frustration. So just pay very close attention to how you're getting your answer and typing it in. They do have those help videos in Delta Math, so if this wasn't enough today, please go back and watch one of those videos. It's linked into the assignment itself. All right. We are not going to do this one. We kind of talked about it already. Your homework tonight is in Delta Math, and it's titled Polynomial Division. There's some with long division, and there's some with synthetic. All right? Awesome. Everybody on Zoom, have a wonderful day. If you need any help, you can come back to this Zoom link at 12:15 to 12:50. Adios.